get some salad.
Me too.
Start digesting.
Thank you, Danny, for your help. That was awesome.
Well, I'm actually getting
Let me show you how to use this bad boy.
You're going to do it.
See what the hell's going on.
Yeah, see, I've heard of that too.
Not like last time.
And then you're like, oh, too much water.
I cannot.
Now, because I'm not quite the geek I should be, I couldn't figure out how to put this into your stat bank. So it's not in your stat bank. Anything I ever give you, like I just did, is in your program menu, which is the button directly under stat. So if you press the PRGM button, you'll see, you probably won't see as much crap as I have in mind, but you'll see all those programs I just gave you, maybe a few other things from other classes that you took. So you'll see probably at top, dist draw and dist fill. I'm assuming those are the two that you guys have at the top of yours, I'm guessing. So go ahead and grab dist fill, whatever number that is, or if you want to just enter it. When I say grab it, just hit the number that corresponds to it. And what it does is it pops you out to the home screen. And from here, what you'll do is you'll select it by pressing enter. It'll start running it. Now what you have to have before you start this program is an idea of what you want to build. So it's going to say smallest x. You in your mind have to know what x is. So, oh, x is the number of girls per flock. And then you have to know what the limits on x are. The limits on x are, well, I could have no girls up to however many. Let's build my flock again if that's okay. Yeah. So 0 would be the smallest number of girls you could have. So press 0, then press enter. And then the largest number would be 4. And you press enter again. Now at this point in the game, if you were to stop the program and look at your stat list, it says 0, 1, 2, 3, 4 in L1. That's it. Now it wants to know what it should put in L2. And for the purpose of the discussion for the next couple days, it'll be binomial. So grab 1. And you have to then supply it with that probability. So the one we were using was 0.9. We'll use the 0.98 in a second, Katie, too, so we can compare and contrast, yeah? So 0.9, it was good, I love it, I love it. And then it says done. Now at this point, it's like, okay, we're used to like iPhones, like want something to ding or flash or cook dinner. But it's done everything it needs to do. If you look at your stat editor now, there's your distribution waiting for you in there in L1 and L2. And now you can take the average of that distribution. See, that's the whole point. The whole point of this was getting you to the point of something you can then take an average of. And how do you take an average? Old school. Stat, cal, 1 bar stats, L1 and L2. And there's your 3.6 average up top there. There you go. Merry Christmas. A little bit early. Merry Christmas. You're welcome.
Happy Thanksgiving.
So, happy Thanksgiving. Hey, chickens, like a turkey. So now what I want to do is I want to analyze. Katie said her grandma, is that right? Said they were quoted 98% from their breeders, not 90. Well, let's see how that changes the average number of girls per 4-bird flock with a reliability of 98 versus 90%, shall we? Let's do it. Program, you have to run dist fill again. We're going to start all over again. All over again. Same flock, we're still building 4 birds, so 0 through 4. Fill it with binomial. Fill it with binomial. And now change probability to 0.98 instead of 0.9. The thing you want to kind of keep in your head is ask yourself, is it a coin flip? If you can say yes, it's binomial. Now coins, we always think of 50-50, but coins don't have to be 50-50. They have to be something and then 100 minus that something. So buying a chicken is a coin flip. It's a loaded coin. It's 90-10, or 98-2, or 60-40, or whatever it is, but those two things have to add up to 100%. That's what makes a binomial binomial. The most popular, of course, is a coin flip, 50-50. But if the coin is biased, it's still a coin flip. Okay, probability 0.98, here we go. Shall we go look at the distribution first? There it is. Look at the differences. Look at the difference. Remember what this was in ours? Full board, I think. That's what it was in ours. Huh? Look what it is for 98%. Ah, very, very interesting, yes. How does it change the average? Whoops. Oh, scheiße. Oh, scheiße. Hang on. Oh, crapple. Hang on. Too many, I'm trying to swear as many languages as possible. Let me run it again. Damn thumbs. It's like my thumbs are like not iPod or TI-83 compatible. I have this problem spelling on the iPod. My cheek is not iPhone compatible. Stat, calc, L1, L2, 3.92.
It's really interesting how much the having 3 changes. I mean, it's 0.92 versus 0.65, but it's 0.075
Versus 20, it's 4 times bigger here.
Yeah, that's
It's amazing, and this is the difference. That's why I question the guy. How do you know it's 90%? Is that measured, or is that just kind of like a shooting from the hip? Because if it's 90 versus 95, that's a humongous difference. And you guys will learn in your last project, when a false positive rate or a specificity or a sensitivity of a test is at 95% versus 99% versus 99.9 versus 99.99, that is ridiculously higher over. It might seem like, we often say like, oh, 99.9999, sure. No, you're not. The kind of precision that requires is immeasurable. You can't get that precise. And this is why. This is why that 8% makes a humongous difference. We often hear the word, the 90 part, and we just tune out the rest. Don't tune out the rest. There's a humongous difference between 90 and 99.99994. Does that make sense? You guys buying that? Beautiful, 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 beautiful. So now here's where the beautiful part is. I had a buddy, Mike Smith. You might know him. He was working at COCC. He works for College Excel. Good friend of mine. He has a flock of 7 chickens. 7 chickens. 7. And he went and bought 7 pullets. And he came back, and one was a rooster. And he was upset. He wanted to go get his money back because one of them was a rooster. And I said, before you go demanding your money back, you might want to have a mathematical argument as to why you should get your money back. So let's see. Does Mike have a case? Should he demand his money back because he got a rooster? Let's answer it 2 ways. First, with High Desert Ranch and Homes 90% estimate. Secondly, with Katie's grandma's estimate 98%. Let's answer it 2 ways, shall we? Have at it. Have at it. Is it binomial? Still. So we're going to run this bad boy again. Just Phil. What's your smallest X going to be for Mike's chicken flock? 0. What's his largest X going to be? 7, because he's buying 7 birds. He wants 7 girls because he wants 7 laying hens giving him eggs. But wanting something and getting it, as we might see, is slightly different. Then it asks, is it binomial? Yes. With probability 0.9 for starters. We'll adjust it to Katie's probability to set, because I don't know where Mike got his chickens from. He didn't tell me. All right, here we go. It says it's done. The first thing I'm going to do is I'm going to hide the distribution and just go straight to one of our stats. On average, Mike should get 6.3 hens. Could we have gotten 6.3 without doing this whole song and dance? How could we have gotten 6.3 without doing this whole song and dance? 7 times 0.9. 7 birds times 9% chance of getting a bird is 6.3 birds on average. That's closer to 6 than it is to 7. Which means, Mike, sorry, you don't really have a whole other argument. Here's something else to think about. Look at the distribution itself.
less than 50%.
Right? There's a higher chance of all girls. But it's less than 50, and this is still pretty high. So in other words, the only way Mike would have an argument, in my opinion, the only way he would have an argument, in my opinion, is if this were way, 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 way small. Now, let's redo the problem with Katie's 98% and see how it comes out, yes? I'm sorry for the somewhat clunkiness of having to go back and rerun it each time. I haven't quite fixed that bug yet. To quote a wonderful movie, please excuse the crudity of this model. We don't have time to build it to scale and paint it. 0.98 this time, yes? 0.98 this time. Okay, I'm going to run the average first.
Oh yeah, that changes things.
We'll change the average first. The average should be 6.86 now. Mike has more of a case looking at just the average. And additionally, looking at the distribution.
Yeah, 86.
Look. You got 12% is 1 in 8. Now, it's still not ridiculously low like these are, but it's definitely on the low-ish side. It's more evidence in this case than it was in the previous case. And all that because of 8 percentage points. Isn't that amazing? But when you apply it to 7 different birds, it changes significantly. Pretty well. There you go.
Is there any way to use the program and put it in L1 and L2, and then the next time put it in L3 and L4?
Great question, thank you. I didn't code it to do that because I tried to keep it streamlined. Did you hear what Danny just said? I was thinking about this as we were comparing Katie's to mine. There's a way around it though, not a programming way. I'll show it to you. So I'm going to rerun my flock again with my 90% probability. Thank you for this question, Danny. So program, dist fill, smallest x 0, largest x 4, binomial 0.9. It's done. And now if you go back and look, it's going to be sitting there in L1 and L2. What you could do is now bump over to L3 and type in L2 in L3 and it'll copy those numbers over. Now you can rewrite the program, and I don't think I have the code clear L3. Let me see if I'm a lying bastard. That might be.
Wait, I missed how you break it.
Don't worry about it. I'll come back to it. I'll come back to it, man. I promise. I just want to see if I'm a lying bastard first. I'm not. Good. So all I did was I did the original flock, and then I put the blinker on top of L3, and then just typed L2. So L3 essentially equals L2, and it copied the numbers over. And then I can rerun the program, maintain the old probabilities, and put the new ones next to it.
Okay.
Does that kind of make sense? You'll have to do this very rarely, but that is a way to do it.
Okay.
And it would be nice to code it that way, but at the same time, it's like, for the amount of times you'll use it, it's probably easier to memorize this kind of, don't ask me, and I'll tell you how to do it again. But this is nice, because you can do a side-by-side comparison now and see where it really, really changes, and where it therefore has to have a ripple effect now. It doesn't change the low end all that much, but it changes the middle quite a bit. You made me think of something else when you said that too, that was awesome, Danny, thank you for that. I can't remember what it was now. That's okay, it'll come back. So the big idea is this takes away the equation that you need. Go ahead, ask me that question.
Well, I was just going to say, is that why the margin of error doesn't matter that much the larger the population?
Very, very, very nice. The margin of error, I'm going to answer this question way better in 2 weeks, I promise you that.
Okay.
Because I want to build this idea of distributions even further and even more. I want to make it continuous. Let me give you a snapshot where we're headed. I'm not going to ignore this question, it's a good one. So this is all discrete, number of girls per flock of 4. Pretty soon we're going to see number of times Max puts his shoes on correct per 10 trials, and things like that, number of, count. Before we get into margins of error with computation, I want to bring the continuous world in, which we'll do on Wednesday after your exam. We'll start into that after your exam, maybe if we have time. Right? I want to go back into binomial after your exam. You won't need the entire day on Wednesday to do your exam. I'm thinking 45 minutes to an hour, then we'll do some more binomial stuff. Next week, if not before, we'll get into those continuous distributions, and then we'll talk about the margins of error with the idea of both discrete and continuous at the same time. It just makes more sense to kind of keep building that. But it is at work here. It is at work here, it's just underlying, and we have to start sampling again. And I promise we're going to do it. Give you a bit of a paused answer. Let's go on again. Oh! Another program I gave you, you might have noticed it is called dist draw. For those of you that like two-dimensional looks at these things, once you run, I'm going to erase L3 real quick. Actually, no, I'm going to copy it back over. So I'm going to put my flock back together here. So this is my flock again. Okay. Once you have a distribution from dist fill, you can then run the program dist draw, and what it'll do is it'll give you a graph of the distribution with points. So each of these points is one of the points on the PDF or on the t-table, and then you can trace it. So it's the exact same data that you get in the t-table, but it gives you a three-dimensional look at it. Now, is this important? I don't know. Students, they use it occasionally. It's way more, I think, useful to use the dist fill than the dist draw. But this is a way of drawing any distribution that you want to it, if you want a second dimension, versus just looking at it in t-table form. So I think students use the other one more, though.
So this is just a more direct route rather than going to stat plot and picking the graph.
Exactly. And the thing is, this is set up to run a frequency polygon with markers. So it won't run a box plot, it won't run a histogram, it'll only run this shape. Now it does get interesting. Remember when we did the flock of 20, I think it was? So let's go 0 through 20. And we'll use 0.9 again, I guess, for grins. So now it's done. If you then go to that dist draw, you can see that the most likely outcome is no longer the last one. It's now harder to get all girls than it is to get all girls and one boy, or all girls and two boys. You can see that all girls and two boys is the most likely outcome. And this is why I put your question back a little bit, Renee, not intentionally, but we're going to get into what is that starting to look like to you? What is that curve starting to look like? It's starting to look like a bell shape, and the bell shape will be inevitable. We can fuse the binomial to bell curves if we satisfy certain conditions, and that's kind of where we're headed next week, so right before Thanksgiving.
Can you trace this and see what is?
You sure can. If you hit trace, you begin to see how unlikely these guys are over here. And then eventually, once they start rising off the axis, there's that 19% that you guys said were pretty, when you get 17 girls and 3 boys, there's 18 girls and 2 boys, there's 19 and 1, and there's 20 and 0. So you totally, I set it up so you can trace it too, for sure. I gave you 3 more programs. One's called Normal, we'll get into that next week. One's called Goth, you won't get into that until 244, and one is called Calc, which is also 244. So. And if you don't take me for 244, just send me an email next term. I'll tell you how to use those things. Cool? All right, kids. We'll see you on Wednesday. Don't worry about the binomial stuff anymore until after your exam Wednesday. Then we'll get back into it. And then we'll start answering your next question with more specificity. Great question. Thank you, Jenny, for your help again. That was awesome. Saved a huge chunk of time.